Hello, welcome to Notes 1.5. I hope your first few days at school have been really good. And here we go. Today we're looking at 1.5, several vocabulary words that you're going to recognize from the past. Our first task here is given the graph of f of x, answer the following questions. So from this graph, they want you to fill out a table of values. One thing I suggest is that you always read your graph left to right. Okay? So, x and y. Here's our leftmost point. It's -5, 1. This point here, -4, -2. And at 3, we're at 1. So basically, -2, 5. Oops, -3. And then -1, 4. You may want to pause this for a second and see if you can fill the numbers in and then check them and see if you got what I got. So if you want to pause, go ahead. Otherwise, I'm going to keep writing the points down. 0, 4. And then, of course, we can see it's 1, 2, 3, 4, 5. So x is 1, 2, 3, 4, 5. And what do we want to fill in? Where x is 1, y is 4. X is 2, y is 5. Where x is 3, y is 1, where x is 4, y is -2, and 1. Okay, this is going back and forth from a graph to a numeric representation. Remember, we talked about 4 things last time. In this example, we're really comparing a graphic representation to a numeric representation. There are certain things on this graph that are really important. Critical points, x-intercepts. Where are the x-intercepts? Well, there's 1 here, there's 1 here, 1 here, and 1 here. An x-intercept occurs anywhere that you cross the x-axis. And I wasn't real nice on these. I didn't give you pretty ones that are just where they should be. Do you have to do a lot of work to figure these out? No. You could use this point and go to all the trouble of writing the equation of a line, but you don't have to do that, because you can tell from the slope. Let's look at this. We can see this has a slope of -3. You go down 1, 2, 3, and over 1. So if it took you 3 boxes to go 1, how big is each box? Well, each box goes to the right a third. Look at this. You go down over 1/3, down over another third, which makes 2/3, and down another one, which makes 3/3, or 1 space. So this is 1/3 over from the -5, which means it's 2/3 over from the -4. So that is -4 and 2/3. And yes, you have to work with fractions and you must not panic. Now when I look at this one, I feel like I've done 2 jobs in one, because I look at the point over here. And is it in the exact same spot? Yes, it is. Instead of writing that twice, I can write plus or minus because it's on both sides. Our other x-intercept is right here. Why don't you pause the video and take a second and see if you can figure out exactly how far that is. I'll do it for you, but pause, try it on your own, and then check with me. Okay, so if we look at this, our slope is 1, 2, 3 over 1. So our slope is 3. So if I go 1 down and I go over, I've gone over a third, so that one is -3 and 1/3, 0. Okay, and then we see another one on the other side, so we can put a plus with that. Remember, it's asking us for critical points, x and y intercepts. If it's asking for a point, we must write it as an XY coordinate. So just saying 3 1/3 is not good enough. We have to pair that up with a 0. Y-intercepts, how many? There's 1, and it's right up here at 4, so that is 0, 4. Increasing and decreasing intervals. I think this is easiest if we color code. I'm going to color my increasing intervals yellow. Okay? I really love to color code on graphs. It makes it easy. It's increasing if your pen is increasing when you trace it. So if I were to write here, my pen moves down, that's not increasing. But if I look here, if I move my pen, it goes up. Remember, we always go left to right. You can't do your pen this way. That's going right to left. We always go left to right. So there's increasing and there's increasing. Okay, what about decreasing? I'm going to trace that in green. This is going down, this one's going down, and this one's going down. So I can see those are decreasing parts. What about constant? Well, let's highlight that here in red. So I'm going to color constant in red so we know it's red. I'm going to do the decreasing in green. I've tried some other highlighters and some of them get too dark. That's why I'm only using the yellow one today. I've got a problem though. Does this graph stop on the edge? How do I know? You can tell whether a graph stops on the edge based on what the last point looks like. And I'm going to sketch one in for you real quick. If you have a graph and it looks like this, okay, those, look at the difference between that graph and this graph. Okay, if I'm looking at this graph, it has very visible points. That means that graph stops, and that's the edge. If my graph looks like it just stops because it runs out of room, I have to assume that it's going on forever off the screen. Okay, so when we look at the one that you have, can you see big points right here that are obvious points? You can't. So we're going to assume that this goes on and on forever and that your calculator ran out of room. Okay? If I want you to stop on a graph, I will put an exact point right there so you can tell. And oh, don't go any further. Okay, so increasing intervals. Well, remember, read x. We always read the x value. So this is -4 where it starts. This is -2 where it stops. So I'm going to say -4 to -2. I'm going to use brackets for increasing or decreasing. You can put a note that some books use a bracket always, and some books will use a parenthesis if the point was decreasing and is now increasing because it's shared between the two. To remain consistent with our calculus class, we are going to use brackets. Okay, and right here, from 1 to 2, we're increasing. And here, from 4 to infinity, since it goes off the page. Infinity is always parentheses, okay? Now, if I did give you a big open circle, you would use a parentheses. But if it touches this, you're going to use a bracket. Decreasing, where is it decreasing? Well, if it goes off the edge on forever, we're going to say it starts at -infinity and decreases to -4. And it's decreasing from -2 to -1. And it's decreasing from 2, right here, to 4. And then where is it constant? Constant means that it's flat, and it is flat right here, so that's from -1 to 1. Okay? We've got some more points that we want to make clear, and those are minimum points and maximum points. Again, I think it helps to color code, so I'm going to color my minimum red. Minimum means what? Minimum means bottom. There's a bottom point. There's a bottom point. And when we say minimum, we're looking at a vertex, so we're looking at where it changes directions. I'm decreasing, now I'm increasing. Where I change from decreasing to increasing is what we're going to call our minimum and maximum points. So where are the maximum points? Those are going to be up here, right there. Notice I was increasing, now I'm decreasing. We're not going to call these minimum points because I'm decreasing and then I'm constant. I don't go directly from decreasing to increasing. So where are my minimum points? And it's a minimum because it's the lowest to those around it. It's actually a relative. This is an absolute min because it's as low as it goes. We don't have an absolute max because it goes forever. But we have these, we can call them a relative max. Okay, the minimum is at -4, -2. And this is 4 to -2. Do I have to write 4, -2? I can simply put a plus there, and it saves me time. Maximum, our maximum point is at -2, 5. Whereas our other maximum is at +2, 5. So you save yourself a little space. Remember, a vertex is a point, so you must write parentheses and have your x and y values. What's the domain? Domain means left to right. So if you look at this, how far does it go to the left? It goes forever. There's an arrow. So that's negative infinity. How far to the right? Well, we got an arrow there too. What's the range? Remember, this is left to right. I want you to, you've got to really remember domain. And what's range is bottom to top. If you write it backwards and put the top number first, it's wrong. So we got to go bottom to top. Where's the bottom? Well, the bottom's right there. So it's -2. Where's the top? This is not the top because we've got arrows. Remember, these arrows are going to go forever, so the top is going to be at infinity. Okay, even or odd symmetry, this is review. Even symmetry means it's reflected in the y-axis. Odd means it's reflected in the origin. And how you can tell is in the y-axis, x values change sign. In the origin, both x and y change sign. So if you look at a table of values, which we have up there, look at your y values 4 and 4. Notice the x's change sign. Look at your y value 5 and 5. Notice the x values are exactly the same, but it has changed sign. We're not going to look at the 0 one because what happens here is 0 is like our mirror. So for even symmetry, you can cut that graph in half and you get a mirror image on both sides. Origin, if you want to look at the graph, an easy way to remember that is if you turn it upside down, the graph should look exactly the same, and you can see it doesn't. It was in the top, now it's in the bottom. If you have origin symmetry, when you flip it over 180 degrees, it's going to have the exact same picture. Okay? Find each of the following. You're looking for points, and you can use your table, or you can use your graph. If you had an equation, you could also use your equation. We didn't give you one for this one. So f of 2, if I look up at 2, that means x is 2, y is 5. Or you could look at x is 2, y is 5. So pause me for a second and you fill those out. So hit pause, fill them out, come back, and I'm going to fill them in too so you can see if you got them right. Okay, we'll go through these real quick. Notice that none of the x's repeated themselves, so from the table you can tell it is a function, or you could come over here and you could look at the vertical line test and it would pass. So this is a picture of a function, okay? The one I want to point out is f of 2 plus f of 0, or f of -4 plus f of 0. So f of -4 is -2. F of 0 is 4, and all you do is add those together, and that's how we got that, okay? F of 5 times f of 2, you just look at f of 5, or if you look at 5, it's 1, times f of 2, which is 5, and 1 times 5 is 5. Now f of 8, this doesn't even go to 8, so how can you figure that out? Well, it's easy, because you know that this slope is 3. So right here, to go from 4 to 5, I go up 3, so I'm at -2 and I go 1. Well, if I were to go to 6, 7, 8, I'm at 1. If I were to go to 6, I'd go up 3 more, so I'd be at 4. Then if I were to add 3 to get to 7, I would be at 7. And then if I were to add 3 more, because I'm going up 3 and over 1 every time, when I got to 8, I would be at 10. So you can just use a little deductive reasoning and follow the pattern and know that the x's each time on this particular piece are going up by 3. Hopefully that makes sense. If not, check with me tomorrow. So there you go. Check your answers. Make sure they're right. And I wanted to give you a tip on your notes. If you have a question, let's say you don't understand vertex, put a note to yourself to ask me about that next time we have class. I also recommend you keep a note card out, and if we come across formulas and you don't have them memorized or something like that, write it down, because you know that that's memory work that you'll need to work on, and that'll help you also as we go. Remember, you can pause me anytime, take a break, go have a snack, watch a movie. Okay. Next page. Given this equation, find the following. Well, let's see. Do you need a calculator or don't you need a calculator for this? Well, let's check. There will be a lot of parts of your test that you don't get a calculator for and some that you do. Is this one you would have a calculator for? Well, look at it. Can you factor that? Can't factor